Hi, I'm Ryan Furness,
And I'm Brendan Henrich.
and today we're talking to you about 5G RedCap. "5G RedCap" is kind of the standard was done by this kind of project called the 3GPP that unites 7 telecom standard development organizations, and these kind of include like ATIS in the US, there's ARIB, TTC in Japan, TTA in South Korea, CCSA in China, TSDSI in India, and then ETSI in Europe and the rest of the world. 5G RedCap started with this 3GPP organization trying to figure out how do we bridge the gap between full spectrum 5G and LTE CAT 4? How do we kind of bring about mass adoption? And so 3GPP played that pivotal role, kind of bringing about simplifying 5G for specific use cases in the IoT space.
5G RedCap, it stands for reduced capability. And as Ryan said, it is a streamlined version, of standard 5G targeted for devices that don't require the massive data rates that 5G otherwise offers, including IoT devices and wearables. The key technical specifications and capabilities of 5G RedCap include using the same bands that 5G does, but using them in a reduced capacity way. Namely, the bandwidth of each of the channels is reduced pretty dramatically from 100 megahertz in normal 5G down to 20 megahertz in the FR1 frequency band, which is typically known as the sub 6 gigahertz band. And further, the bandwidth is reduced in half in the millimeter wave band as well. What this means is that you don't have to have as expensive antennas to utilize this technology. And your data rate is reduced, but that's honestly a good trade-off for devices that are looking for lower cost solutions. And another great feature is power consumption for 5G RedCap is significantly reduced. 5G RedCap devices can actually sleep for longer periods of time. A typical 5G device can only turn its radio off for about 3 seconds. But with 5G RedCap, you can actually go to sleep for upwards of 3 hours, dramatically reducing your overall battery life.
Practical use cases for 5G RedCap include wearables, everything from smartwatches and fitness trackers that require reliable connectivity with low data rates, industrial IoT, sensors, monitoring devices in factories that need robust connections without high data demands, smart agriculture, so devices like soil moisture sensors and weather stations that collect and transmit data intermittently, and then smart city infrastructure, parking meters, street lights, environmental sensors, everything that connects kind of to the grid. These all benefit from efficient, low-powered connectivity. One of the other advantages from 5G RedCap is that it provides cost efficiency. So having that lower complexity and fewer hardware requirements, it helps reduce the cost for both the device itself and the network operators.
In current 5G networks, 5G RedCap can be implemented through software upgrades on the carrier side. Because RedCap uses the same frequency bands as 5G, the actual towers and physical deployment does not need to change. This is a major benefit of 5G RedCap. Ryan, what are the carriers today doing to implement 5G RedCap?
Yeah, so RedCap is just a really exciting technology just from the carrier's perspective. AT&T actually became the first carrier in June of this year, June of 2024, to introduce 5G RedCap into the IoT sector. Commercial service is now available in areas like Dallas, and kind of there's plans to spread it all along the West Coast with full deployment across the country in 2025.
But of course, there are challenges that people are going to face in, deploying these RedCap solutions. One thing that comes to mind for me is if you're using existing network infrastructure and you're adding a device that uses a reduced bandwidth, you want to, manage the network in a way that these lower bandwidth devices don't harm the throughput of the full featured 5G uh, devices. So there are challenges, but they're known and being worked on now. Ryan, any other challenges come to mind for the carriers?
And with any sort of new technology implementation, we see there's always going to be a kind of lag in terms of mass adoption, just because it's trying to get the technology stabilized, and it's hard to get customers moved to a new technology if they're currently happy with one they have. Different carriers are making sure that the RedCap devices work seamlessly with the existing 5G infrastructure that you kind of mentioned before, so that there's no drops, no interruptions, and things can be kind of grow further and further.
Specifically, 5G RedCap inherits the security features that were implemented for standard 5G. Some notable examples include network slicing. Uh, Network slicing is the ability for the carriers to separate critical communications, say between an ambulance and a hospital, from communications on sensors measuring, water pressure in a low priority environment. This nearly physical separation of networks allows for, better guards against different sort of attacks. Encrypting the data as it moves over the air is upgraded in 5G. It uses ciphers such as AES 256-bit to enable security as the data is moving over the air. And, another concern is the ability to be private on the network. Historically, cell phones have been exploited by the ability to actually find somebody's phone because their subscriber number was sent over the air in plain text while looking for different cell phone towers. This was taken advantage of in the famous Stingray product, often used by people to find individuals as they're moving around. But 5G avoids this privacy concern by never sending out the true identity, but rather a privacy-preserving identifier containing the subscriber concealed identity. Latency and speed are key metrics when it comes to evaluating cellular technologies. With 5G RedCap, you'll see speeds in the ballpark of Cat 4 devices, namely 100 megabits per second, which is lower than your standard 5G, but often, faster than LTE CAT 1 or even 4. Latency is a really good question, and it's, really a trade-off in regards to how often your device is sleeping and taking advantage of the longer, radio silence modes available in 5G RedCap. Latency, however, is aimed to be around 10 to 20 milliseconds for devices that need that quick latency as a key point of the product. But of course, if latency is not super important, you can increase your battery life. Let's talk specifically about what cost is reduced. So with 5G devices, typically you will have like 8 antennas. These devices are, they have fast data rates because they have, 4 antennas to receive packets and then 4 antennas to send packets back to the tower. This is awesome, but it's expensive. 5G RedCap reduces this requirement to only 2 or 4 antennas total. We call that 1 by 1 or 2 by 2 MIMO, which stands for multiple in, multiple out sort of radio technology. So reducing the number of antennas reduces the cost. And additionally, 5G RedCap devices can operate in a lower power class than typical 5G devices. Specifically, in the millimeter wave bands, RedCap devices can operate in power class 7, which is a much lower total power output device, which is going to reduce the cost for the integrated amplifier.
Industries adopting 5G RedCap include manufacturing, agriculture, healthcare, industrial, and logistics involving LTE CAT 1 or LTE CAT 4 could tend to move towards 5G RedCap. And these could encompass anything from alarm systems to video surveillance, point of sale terminals, first responder videos, or even like smart grid applications.
It's interesting. In the future of RedCap is actually a new standard called enhanced RedCap or e-RedCap. And this actually further reduces the capacity to target different markets, to target even lower data rate, lower power industries. E-RedCap will reduce speeds to 10 megabits per second, down from 100 with RedCap. And this puts it in the same category as Cat 1 or Cat 1 bis. It's the future-proofed version. But when developing a device that utilizes the 5G RedCap cellular infrastructure, customers need to go through many levels of certification to ensure that their device is playing by the rules set by the carriers. It's the same as 5G devices, it's the same as 4G devices, where the customer needs to go through regulatory certification, such as with the FCC in the United States or IC in Canada, then industrial certifications, such as PTC-RB testing, to ensure that roaming is not going to hurt networks that you move around to. And lastly, carrier certification, such as with AT&T and Verizon, going through a battery of tests to ensure that you play nice and by the rules on their network. So, these 3 categories of certification are the main challenges faced, during development, and, Symmetry can help in these regards by providing best practices and examples for you to follow.